thank you very much for the introduction. And I was the chair of the IPCC's sixth assessment report, responsible for the latest IPCC report released middle of last year. And I'm going to present this morning key findings of that IPCC's latest report. And my remarks will consist of in three parts. First, there are things that we just cannot do anything about, and then there are things that we can, and then thirdly, there are things that we should do, and those are the broad framework of my remarks this morning. Let me go back to the next one. Okay, the human influence has warmed the climate at a rate really unprecedented in every measures, and the report indicates that various indicators show that the way humans are really experimenting with the Earth in its various systems, including climate as well as biosphere systems, and it is a very dangerous experiment. We should not get involved in this experimentation at all. The global warming will continue regardless of what we do today, reaching 1.5 degrees Celsius in the first half of 2030s, and it will overshoot 1.5 degrees Celsius by about 0.1 degrees Celsius for several decades, and then decline to 1.4, slightly below 1.5 degrees by the end of 2100. So when we say limiting warming to 1.5, the date is 2100, not 2050. And we will be able to achieve this goal if the global emissions peak from next year, and then decline very rapidly to net zero by 2050. Obviously, that's a very tall order. However, that's what the models of climate science indicated, and it's been verified by a number of independent sources. This implies that the world needs to take immediate action to adapt to the continuing global warming to 1.5 and then further. And the immediate action they also needed to reduce emissions, to limit the temperature overshoot beyond 1.5, because any overshoot and return will not guarantee us going back to the original state of climate of 1.5, but it will involve, the overshoot will involve a irreversible damage to the system and to us. Currently, over 70% of global emissions are from developing areas, and about the same percentage of global emissions are also from urban areas. So this indicates what should be the key focus of a climate action. The impact of current warming is obviously quite severe, and this slide and the next two slides, I will show you just overview of this worsening impacts of climate change, not only for current warming of 1.5, 1.1, and then 1.5 and 2 degrees and 3 degrees. And as mentioned before, currently 3.6 billion people are vulnerable, very vulnerable to the changes in climate. And the current damage being felt through the agricultural productivity, the slowing down agricultural productivity, and the decrease in the fisheries yield. The catch rate of fisheries are declining very rapidly, and there are some very vulnerable ecosystems in mountains and Arctic. Some of those are approaching irreversibility in its services to the human systems. And obviously, the intensity and frequency of extreme events increasing. Therefore, the continuing warming toward 1.5 will multiply risks to ecosystems and human systems. And it's been known, very well known, that the coral reefs, which is very key, critical to ecosystems for the human's food chain arrangement, in great danger, not only in the current 1.5, but also in 1.5, 1.1 degrees warming. But most of the coral reefs will be severely damaged, 70 to 9% of it, by the time we reach 1.5 global warming. Arctic ecosystems, dryland regions, and small islands and least developed countries are particularly vulnerable to this global warming of 1.5 degrees. And the worst impact of the warming approach 1.5 will be this cascading and compound risks through the food, energy, and water relations. And I'll mention briefly about how adaptation was quite inadequate in dealing with and addressing this nexus of the food, energy, and water. With 2 degrees C warming, everything will get uglier, and hunger will increase, and especially in sub-Saharan Africa, South Asia, and Central America. And also heat waves and the droughts become much frequent and intense. And with 3 degrees C warming, the high extinction risk again were identified through numerous assessment of risks. And flood damages will be particularly severe as warming moves toward 3 degree level. And then obviously all this warming will give us very serious implications about the tipping points. And the sea level rise and continuous glacier melts, permafrost carbon loss, and ice sheet instability, and also tropical forest, all are subject to our inability to control the Earth system moving toward the tipping points. And especially when the system temperature moves from 2 to 3 degrees, science identified that Greenland West Antarctic ice sheet will be lost almost completely and irreversibilities. And the ocean acidification and ocean deoxygenation global mean sea level will continue to increase 21st century, just lastly because of what we have contributed to the global warming by this day. So the immediate adaptation necessary, as I mentioned before, but so far those adaptations are very fragmented and limited, and the gaps, adaptation gaps, are quite severe. And also we've observed lots of limits to adaptation appearing in various systems. Again, these complex risks from food, energy, water, health nexus have not been dealt properly through the adaptation actions. And importantly, you see at the last bottom of this slide, the ecosystem-based adaptation. We so much value highly of this approach. However, this adaptation approach faced hard limits to continued global warming. We found that if warming, well, certainly warming will go beyond 1.5, and that means the ecosystem-based adaptation will face a tremendously difficult times to have its effectiveness. The effectiveness of adaptation will decrease with increased warming. This is simply how the nature works. Agriculture, all those adaptation measures so far we have adopted will become less effective as warming continues beyond 1.5. And as I mentioned before, ecosystem-based adaptation, not so much of a solution with warming going beyond 1.5. And many ecosystems, both land and water, will become very not so quite effective around 1.5 and going beyond. And the freshwater resources and also the glaciers and snow melts will present a tremendous challenge to the people living in some hotspots areas. Now, with this with these constraints, we also observe that the emissions continue to increase. That may not be the surprise to all of you, but it is surprise to see how the emissions continue to rise, given the risks we have experienced, and we all understand those risks will continue. For instance, the historical emissions measured, estimated for last 170 years, 42% of those historical emissions were accounted by emissions in the last 30 years. Now, this 30 years, that the beginning of that 30 year, in this case, is 1990. And ironically, the 1990 is the year that the IPCC reported in the first assessment report. And then it was just the year that the UNFCCC was established. So it seems to me so ironic that the years beginning from the establishment of IPCC and UNFCCC, the world experienced a very, very rapid increases in emissions. As I said before, 70% of global emissions from developing countries and 70% from the urban areas. And average GHG emissions is currently across 10 regions about 6.9. The lowest is 2.6, Southern Asia, and highest is 19 gigaton of CO2 equivalent in Europe. And 10% of households with highest per capita emissions contribute about 45% of global emissions, and the lowest bottom 50% contribute about 15%. So this is the kind of the interesting distribution between the status of income as well as status of the its contribution to the global warming. The mitigations today, the world has done much effort to reduce emissions, but that's not quite enough. And currently, about 20% of global emissions covered by some kind of carbon taxes or equivalent. And 18 countries, the record shows that a continuous decline in GHG emissions for the last 10 years, which is very good news. And that can be replicated. We hope that can be replicated in other parts of the world. And the policies, economics, and regulatory instruments resulted in, according to our estimate, about 1.8 gigaton of CO2 equivalent reductions. And the tremendous reductions in the renewables, renewable-based power electricity cost, and then also the batteries, cost of batteries reduced drastically, beating any previous forecast regarding that cost development and technological development there. And electricity decarbonization is very much underway, but what's lagging at this point is the decarbonization of industrial processes, which means the production of steel, cement, petrochemicals. Those are the areas that we still we do not have anything concrete to reduce emissions in that important sector. Now, the effect of current mitigation effort will be a 3.2 degree warming by 2100. So certainly this will not be acceptable to all of us. And there will be a warming, overshooting 1.5, going beyond 1.5, and then hopefully about 0.1 degree excess. and then will return back to less than 1.5 several decades later. But as I said before, that overshoot, however that small will be, will have an irreversible adverse impact on the system. That's the reason we should do everything possible to reduce the current emissions in order to reduce the impact of these irreversible adverse impacts. The reducing global temperatures after this overshoot require a carbon capture from the atmosphere. We believe that such a removal of carbon emissions would be about 220 gigatons of CO2, CO2 for the second part of this century. And many analyses of scientific assessment indicates that's doable, although there should involve some cost. The sectoral contributions. Here, a number of technocratic and engineering and economic suggestions, recommendations were made, and some of those are already in place by various entities, including national government and some national governments. And so one thing I want to emphasize is that the current trajectories of 1.5 global stabilization, warming, limiting warming to 1.5 by 2100 assumes that the energy demand will stay at the current level throughout the next 70 years. That's very hard, tall order. And it is not just an imagination by the modelers, but we have investigated various key parameters like efficiency improvement, and as well as the efficiency in the use of materials and other key factors. And technologically, we came to a conclusion that such a pathway possible, but again, it depends upon how the policy will be able to respond to this type of technological pathways. The carbon dioxide removal is necessary, and its cost ranges from the lowest is somewhat below 100, and the highest is about twice that level, 100 per CO2 removed. And then currently, the removal involved with forestry management is the only CDR we have taken so far. But the CDR we need in the second part of this century will be much more than the forest management. Very technology-intensive way of reducing carbon, reducing the stock of carbon from the atmosphere will be needed. My last slide is a climate resilient development. All our analysis indicates that the development pattern has to change from the current energy intensive, carbon intensive, resource intensive patterns to the resilient development. We recognize that the global urbanization, which we expect will intensify for the rest of the century, will give us an opportunity to achieve the climate resilient development. The 50% of our population lives in urban area right now, and accounting for about 70% of the CO2 emissions. And obviously, the population moving into the urban area will increase something close to 400 million people from for the last several years, and 90% of those increase in urban population occurring in the less developed regions, which has very least capacity to adapt. And by 2050, additional 2.5 billion people will be located in urban area, and 90% of that increase in the urban population will be in South in Asia and Africa. And 1 billion people will live in the coastal and low-lying areas, very susceptible to the increased risks from sea level rise and storm surges. So the policymakers and investors and all others has an opportunity to leverage this high density of the urban population, high density of urban infrastructure towards the climate resilient development, urban dimensions. And the 2030 agenda provides a very clear global framework for urban governance and institutions to be an agent of change towards sustainable development. Nature-based adaptation, I mentioned so many times in this session, has a large co-benefits even in or more in urban setting, and safeguarding biodiversity in ecosystems are possible when ecosystem nature-based adaptation applied in the urban setting. So we do have a high hope for joining this climate ambition with the increased urbanization in global as well as local, toward a much better climate solutions. Last slide is cost plus benefit. Assessments indicated that in a globally only when we count the economic cost and economic benefit of mitigation action indicates that those costs overweigh by benefit. Clearly, there's a net benefit of climate action. But the challenge is then how that net benefit we understand existing globally will be translated to the individual net benefit so that individuals can take everyday decisions. However, the aggregate of that individual decisions, individual choice, will also support the global ambition for climate stabilization of 1.5. I believe that's the challenge we face at this moment. Thank you very much.